All right, let's go ahead and try some combo functions. So evaluating expressions with a combination of trig functions and inverse trig functions is sometimes simple and sometimes a little tricky. So look to see where the inverse trig function is located, because it's going to be in one of two spots. So if the inverse function is the inner function, then check the domain. If it's the outer function, then you're going to check and make sure that whatever the answer you're giving is going to be inside the range. Okay, so some of these are going to be really fast, others not so much. Okay, so let's try these right here. So find the exact value without a calculator. So sine of inverse sine of 0.7. Well, these are really kind of nice because what do you remember about having an inverse function plugged into the regular function, or vice versa? Yeah, they're going to cancel out. But you have to make sure of one of these two things. So the inverse trig function, that's the inner function. The sign is on the outside. So is this 0.7, is that in the domain of inverse sine? If it is, then we get to cancel them out and you're left with that number. If your answer is no, then this whole thing would not exist. So it would be D and E. So 0.7, that is in the interval from -1 to 1. So the inverse sine and the sine cancel out and you're left with 0.7. Okay, same type of thing here. So the 2/5, is that in the domain of -1 to 1 for the cosine? Yep. So they cancel out, so that would be 2/5. Okay, sine of inverse sine of 4/3. 4/3, oh, that's not in the domain. That is bigger than 1. That is bad. So we cannot evaluate it. Like, you can't evaluate it if it's not in the domain. If you if you can't plug it in, you can't get an answer, except for D and E. Okay, part D, cosine of inverse cosine of 6. Nope. Same thing. 6 is greater than 1. That is not in the domain. So that is D and E. Okay, moving on to part E. Inverse sine of sine of pi over 3. So we want to cancel them out. We just got to make sure that whatever answer we get is in the range of that outer function. So they'll cancel out. And pi over 3, that is in the range of inverse sine. That's in between -pi/2 and pi/2. That's totally fine. Okay, this way, they still cancel out and we get -pi/3. It's still in the range, so we're good to go there. Okay, part G, they cancel out. We're good with the range again. So that's fine. Part H, cancel out. That's still in the range. It's from 0 to pi. So we're good there. Okay, let's move on to example I. They cancel out. 5 pi over 3 is not in the range. So it's not in the range, so we need to adjust it. So think about where 5 pi over 3 actually is. That would be down in quadrant 4. That would rotate all the way over there. So if you just gave the negative equivalent of that, if you just gave this green angle, that would do it. So that green angle would be -pi/3. So that's how you can really just adjust them. It's really not any big deal with it. You just kind of have to think a little bit. Okay, this one, they're going to cancel out, but again, that's not in the range of inverse cosine. But there's a little trick to this. It's even nicer than this one. Remember with cosine? Cosine's an even function. So you can take this negative and make it a positive. because it comes out the same. And now it is in the range of inverse cosine, and you fixed it. All right, tangent of inverse tangent. They cancel out. So that would be 2/5. Tangent of inverse tangent. We're good there. Remember, the domain for inverse tangent is all reals. So if inverse tangent is the inner function, you could have any number in there and you're totally fine. Okay, it's 4/3. Okay. Let's look at these two. So inverse tangent of pi over 3. So it's now the outer function. So pi over 3, that's in the range, that's okay. Inverse tangent of 0, they cancel out and you get 0, that's in the range, that's okay. Oh, sine of inverse tangent. Oh, my word. Now we're going to start to mix and match them. Ooh, this is going to be a good one. Okay, so with these, they obviously don't cancel out because they're not inverses of each other. So what do we do? Well, to start, we're going to draw a triangle. Triangles are going to be the best with these because they don't always have to be something on the or on a 30, 60, 90 triangle or one of the coordinates you memorize from the unit circle. It can be any sort of numbers in there. So like the 1/3. So just draw a triangle. Label your sides. So opposite over hypotenuse. And then get the, or opposite over adjacent, sorry. Get the hypotenuse, which is going to be √10. So that is what the inverse trig function does. It sets the triangle up and gets all your sides going. From here, now you just have to look at this outer function. So we just want to do sine of this triangle that we just labeled. So sine is going to be opposite over the hypotenuse. So 1 over √10, and if we rationalized it, √10 over 10. And that is probably the quickest way to do them. Like, you don't care what this angle is because you don't need it. You're going to do this outer trig function of that angle anyway. So you don't even need to know what it is. You have all your sides and you're good to go. Okay, let's try it again with this one. Cosine of inverse sine of 8/9. So that would be in quadrant 1. Label your sides. So opposite over hypotenuse. If you did Pythagorean theorem, the adjacent side comes out as √17. So again, that's from the inverse trig function, this inner part here. Now do the outer function, cosine of all of this stuff. So that would be the adjacent over hypotenuse. So √17 all over 9. All right, let's try this one. Inverse tangent of inverse cosine of -4/5. So the -4/5 means I'm going to be over in quadrant 2. So adjacent over hypotenuse. Pythagorean theorem, or if you know your geometry, that side is a 3. So now tangent of all of this triangle. So it would be opposite over adjacent. So -3/4. Okay, and for this one, sine of inverse cosine of 4/3. Oh, wait a minute. Hey, this one's kind of cool because 4/3. 4/3 is greater than 1. That is not in the domain. That is a DNE. Okay, so don't forget to check the domain if that inverse trig function is in, in the inner function, because it might sneak one in there that's going to be a DNE on you. Okay, let's go ahead and stop the video here, and then we'll probably finish off the two sections in the next video.